companies, we were fortunate that GE bought one of them, Nurego, and so we have some other companies, and I see some of the people here, FogHorn and Sage. Sage used to be called Sensify Security, and two companies that come out of our India entity, Flutura and Aptison. And you can see on the right some of the themes that are of interest to us. And obviously today we'll talk about the edge. The next event is going to be on February 1st, and it's on enterprise chatbots. And so it's going to be in Palo Alto at SAP, so I hope you can join us. It's going to be a very interesting event.
All men here and all women there.
Yes.
Let the record show the Italian women did
Oh, so maybe, okay, so my name is TM Ravi. I'm the managing director of the Hive, and maybe we can start with kind of just go a round of introductions, and just feel free to talk also about your company and so forth. I want to first give you my Flavio anecdote. So Flavio was sitting at Cisco as a Cisco fellow and was a kind of passionate advocate of fog computing. Some people at Cisco kind of listened to him, but people outside like us listened to him a whole lot. And so FogHorn was one of the companies that ended up, because of some of the advocacy that Flavio did. Go ahead, Flavio.
Thank you. Thank you, Ravi. It's good to be here with all of you. I am the founder and CEO of a startup that contains the word Nebbia, which is fog in Italian, in the name. So we have two companies here with fog computing or fog reference. We are trying to manifest the dream that we pursued at Cisco from the middle of the 2005 and 9 and more. And it's now coming up. It's good to see it happening. We decided to really build the platform. Is it a platform play, complete stack, optional hardware, but also mostly software, to enable the deployment of applications at the edge, to host, control, and real-time together with non-real-time activities at the edge. And we want to have an impact on the operational side of the story, which is where many of the pain points are appearing and could be addressed with this technology. So I'm very happy to be here with you and ready to participate with passion in this discussion.
Hi, good evening, everyone. I'm happy to be here. My name is Sastry Malladi. I'm CTO of another startup called FogHorn, a Hive incubated company. We are a software company. We provide what we call edge intelligence software platform, particularly for IoT, industrial IoT sector, where we in all of these different industrial environments, ingest the data in real time. We have, sorry about that. So we have a platform that can ingest data in real time from hundreds of, thousands of sensors connected to these industrial machines, whether they are regular traditional digital sensors or whether they're modern sensors like audio, video. We can do sensor fusion as well. And we have a patent pending, what is called a CEP engine, complex event processing engine, using which people can process the data. And then that's how we started. And then we went on to do machine learning. A lot of people, even here now, people think that machine learning is possible, where you can actually execute and do the inferencing of the machine learning models in a small, tiny footprint devices like a Raspberry Pi or even smaller existing PLCs. And then we're getting into AI as an improvisation from machine learning. In a nutshell, who we are is we are a big data processing, stream processing software platform engine, where we ourselves have an engine to execute, as well as we provide several different models. Also allow that's really who we are in a nutshell. Happy to be here.
Hi, good evening, everybody. I'm Ray O'Farrell, and I see I work for two companies up here. A lot of virtualization throughout most of the world's enterprises over the last 10 years. So the software-defined data center. But VMware is a public company, but it's got one big giant shareholder owning a lot of the shares, and that's Dell. So we've got these two companies connected together. As VMware, as a CTO of VMware, one of the groups I manage, and then the management of infrastructure, applications, and so on across them. When we looked at that, and many of our customers, often IT organizations, would come to us and say, how do I now manage all of this new infrastructure which is appearing? How do I secure it? How do I virtualize it? How do I make How are we going to manage, build, and make sure we support and secure this new type of infrastructure? With Dell created a new business division, basically focused on IoT across all of Dell technologies. It's relatively new, and I'm the general manager of that. That brings into the mix all of the storage and storage analytics, because Dell also owns EMC. So it's a combination of these companies that allow us to really look at this whole new world of edge and edge computing.
Which is often the security.
Yeah, Dell Technologies consists of 7 companies, or some are separate companies, some are divisions in the mix. But in there are Pivotal, which you might be familiar for, Pivotal Cloud Foundry. And also RSA, which is focused, of course, on many aspects of security, some of which feed into the world of IoT.
CTO for IoT software for Cisco, a company you may or may not have heard of.
Enterprise data integration, application integration. It's done a number of companies. Its most recent one, Composite, was acquired.
As Rockwell Automation, we focus on pretty much everything which an industrial automation company or a user would be interested in, right? From controllers, how do we take analytics from edge sensors to enterprise system, how we can have a scalable analytics offering. That's kind of our focus. It's easy for a customer to scale their use cases on this platform. Thank you. Good to be here today.
Great. Thank you. By the way, I hope some of you will tweet. So if you do, use the hashtag Hive data so others can follow you. So Flavio, maybe we'll start, and I think question for everybody. Let's just maybe first sort of define and interesting cloud computing. What kind of motivated the need for fog?
With cloud computing. In fact, my marketing guy, and maybe here, he put up this Pac-Man story, and I said, this is not right. This is not. There's a missing link. You want to bring computing bring the same models of software management, application deployment, to the edge, to the cloud, so that now you place the right application, the right function in the right place. If you're going things, but you'll find yourself handicapped deeply. And what we learned is, particularly when you concentrate on the industrial part, we found an immense resistance to the cloud. Cloud is not accepted yet. Cloud is seen with skepticism. In fact, I went into the CIO office of the biggest energy company in Italy, and they trained me before going in, saying, don't. They are very happy with that. If you talk cloud, you'll be kicked out of the office. The reality is, there is a big backlash. It may be overcome in time, but models and technologies that come from the cloud, and with activities that are real-time that come from the operational. So fog is really that, or cloud. Here there's a political story about the naming, but you resolve it very beautifully. The intelligent edge and fog is in the cloud. Everything is in. So it's very good. You're very, very, very savvy that way. But the cloud, and we know what they are, down close to the machines where they have never been. But then you have to bring up once. Real-time control and so on. And when these two merge, that's the beauty of the intelligent edge and fog, and that's where the potential of this evolution of architecture is. And we see it will follow fast for the startups. You're okay.
Any other thoughts on motivation?
Motivation. So, and the cost of moving the data is becoming sizable. We are already seeing robotics companies, BMW, not ready to spend more to take the data through the network to the cloud, paying the cloud fees and all the other stuff. So the amount of data is important. Second is the response time. Many decisions have to be made locally. You don't have time to go out there and back. And this is very important. Here, the 5 big things are scaring the world in all industries. And now, by going there and saying, guys, give me your nice data, I'll do beautiful things and return you some benefit. That doesn't go through. One of the big Italian robotics companies decided for 1 year, we understand. So ownership of the data is very, very important. The other one is obviously the security and so on, the trust that what's going on, what comes from the outside is very dangerous. So there's many, many reasons, but to me, one of the biggest reasons is the evolution of control. Architecture for control in one evolve and become sensor-rich. Learning, all these good things can affect and improve control. To achieve that, you need to make this happen.
Any other thoughts, Sastry?
Yeah, I think Flavio covered many of the points for the cloud. Obviously, cloud has a place for what it is good for. A lot of data processing technologies have evolved in the last decade or so or more. Big data processing, several different machine learning, AI, and all of that. Everything is all good. So you might all be wondering, so what's new? Why can't you just take all of those existing technologies and take it to these devices and call them edge, call them fog? Well, except that there is a little problem. That in the industrial environment, in particular, if you're looking at manufacturing factory, if we're looking at oil and gas, oil drilling equipment in the middle of an ocean, or a wind turbine running outside and out of the wild, you don't have an opportunity to go put a big server computing box next to the machine or next to the drilling machine. What they've got is existing small devices. What we call an IoT gateway, whether they are some ruggedized form of a Raspberry Pi or gateways manufactured by HP, Dell, and so on, right? So those are tiny footprint devices out there. But how do you take all of these hundreds of sensors of data coming in the tiny footprint devices apply this kind of processing that you typically do in a cloud? This is where new technologies need to be invented. And, we are one of those companies that have pioneered that space there as well. There is also a misconception. Sometimes people differentiate between fog and edge, and obviously depending on who you talk to, the definitions are all different, but we interchangeably use the same thing for fog and edge. And remember, what we need to do is to find out what's different about fog and edge and try to solve that problem as opposed to try to reinvent everything that was done in a cloud environment. Now, I'll leave it here without necessarily naming all of the people who are attempting to say, look, we do fog computing, but try to reinvent the wheel and what has been done there. That's not the problem for what people have been looking for.
Any other kind of anything we haven't covered in terms of?
I think the one comment that particularly struck me as interesting is, that's a provocative statement, as noted, but the real power is when these things merge together. The ability to take applications that you develop in the cloud, or maybe do training in the cloud and do the actions out on the edge. There's an inherent power in that, the ability to bring all this stuff together. And I think, like one of the things we do is focus on manage a small number of data centers with a lot of servers, a lot of virtual machines, that type of thing. This world begins to turn on its edge. Oh, bad choice of words. Begins millions of them. And that fundamentally changes how you begin to manage and secure these devices, and in some cases, many little data centers. I think that's one of the more interesting aspects of this that's going to emerge as well. You've changed that whole paradigm, and particularly from security, I think that's going to introduce all sorts of new paradigms and new ways of securing these.
So this is the part where I'm supposed to say something smart?
Yeah.
So there's several points to be made. And if you wanted to have an interesting read, everything that analysts say is wrong, but some of it's useful. And that's look at the title, it's got both the word fog and the edge in it, and we need to decide which we're going to talk about. Recognize you do much different things at the edge than you do at the fog. At the edge, you recall TCP, of course, if possible, if you've got satellite UDT type of connectivity. So you got a lot of connectivity issues at the edge. Also at the edge, you're dealing with at the fog, on the other hand, it's your collection point. It's where you aggregate. Imagine you're doing a city infrastructure project and managing parking. You're not going to want an application that has to maintain 10,000 parking spots. There's about 10,000 parking spots in a city the size of Palo Alto. You're going to aggregate that before you get it to the data center in the cloud. You're not going to do it at the edge, you're going to do it in the fog. And so there is methodology, there's best practices about this. And you're going to do a lot of this work turning the telemetry into useful information while you're moving it through the network. IDC did a survey and said, what are the important issues of IoT? There were 6 issues that were important. Number one, 26% data management. but it's not your ETL, OLTP, DW data management. It's transforming the data on the fly. Seconds, and actually trying to wrestle and wrangle with the data because there's so much data. I mean, we did an offshore oil well project. Yes, we managed to handle all the data from an oil well and all the sensors in the oil well. We felt pretty good. And they said, okay, let's do it for the oil field. You know, we're off the coast of Asia in the ocean. By the way, we have 6,000 oil wells. And we have, 3G connection to the data center. Now we're dealing IoT. You do certain things at the edge, you do other things to far. Before I hand the microphone off, there's one other really important point, and that is we have lived through multiple ages of computing. Batch jobs in the mainframe, holistic, self-sustained applications in many computers, personal productivity apps. Computing, which yes. New computing model based on completely distributed microservices that like this is fascinating, and it's all about handling massive amounts of data.
Some ways, So there are many use cases you couldn't really would have desired to solve anywhere close to the cloud. You would have just kept everything on the participate in those use cases. The interesting thing, we kind of talking to some of our customer, bringing to them kind of we are kind of helping to sell cloud, if I may say at times. While at many times, Edge is truly overall, it makes good sense to look at Edge as a complementing to cloud. And
fundamentally a different compute. Go ahead, Flavio.
I was ready to battle with Jim, but then he really completed saying it was very to in cloud is do things fast, but not the but you're not predictable in the time you'll finish a task. There's no determinism required. Oh, it's all about determinism. No, now you have developed Intel try to get back to do things predictably, both in the network and in traditional IT. Time, absolute time, becomes fundamental here. And now that the things come in computer science and so on. And we go to Berkeley, and these guys don't have enough receptivity on the other side. But that is the key play. And the autonomous car will be one this direction. The robotics and so on. All of this requires a very, very open mind to innovation, and it's going to be fun.
So I heard kind of time microservices, any sort of highly distributed, any kind of diskless, serverless, any other key software paradigms?
Sure. I mean, from a computing standpoint, as I mentioned earlier, right? So the concepts are somewhat similar. We're not trying to reinvent the new concepts. What's different about edge computing and technology, as I mentioned, is that you have less CPU, essentially less compute, less storage, less memory. So how do you do processing in an environment? Typical cloud environment, you just take all of the data, you've got, unlimited almost amount of storage, store the data and start processing them. You can go back in time, process that. You don't have that ability in the edge side. But there are fundamental, what I call constraints in what you're working with in edge computing paradigm. But the concepts of how do you do analytics, how do you do machine learning, how do you do AI, how do you do protocols, how do you do ingestion, how do you do storage, those concepts still apply. That's really where I beg to differ from many people, where people tend to think that, oh, we got to go reinvent about edge computing, and what are the constraints you're working with, and how do you address those constraints to solve the value, the problem for the customer, right? At the end of the day, there's no connectivity from the edge devices to the cloud. We've kind of beaten this to death, talking about lack of connectivity, bandwidth issues, cost issues, latency issues, all that is fine. But when we talk about technology, let's not go and reinvent things that already work. Let's find out what's different about edge and try to solve the problem for that. That's really where I might take the stance on.
Maybe we'll switch gears. We'll start with you. Do you want to talk about some of the, so clearly there are some use cases where you can just push the data to the cloud and it works. What are the sort of the big edge use cases for a company like the two gentlemen sitting on the left? How do they sort of become $30, $100, $500 million companies? What are those use cases?
Okay, that's $1 million question. Kind of like many use cases, and to start with, there are some high-level kind of like optimization of process KPI. Like if you talk about a typical automotive infrastructure, those are kind of simple use cases as well. Plus analytics, predictive. But those simple use cases probably can done right on the edge, some basic form of control loops. A lot of people are able to relate to, and you can always start with them. Then now we are kind of starting to see some unique use cases, which are very specific to customers. If I may say, right, for a line manufacturing, for example, they're kind of automotive or discrete line, latching on the top of it. Those
there's about 10 different reasons that I've thought of for edge computing. Many times, the most useful thing through Modbus, which is common in factories. You see that Modbus of having something body remote with unpredictable latency grab the data doesn't work. You're interested in temperature. Does the temperature change every 50 milliseconds? No. So send the initial temperature up and then tell me. You can do alerting and alarming and reduce the latency. You 4.4. Why? Because the Mantissa and exponent are not common. And so you have to wedge it into dealing with low latency, data manipulation, and making sure that you simplify the process that the application has to deal with.
Any other sort of use cases, right?
The only one I would think, which you kind of captured there, was I think there's an economic model that fits into this as well. In that, one of the analysts, sorry, I shouldn't talk about. It's available today are generated in the internet. 75% of that is generated somewhere on a cloud or a SaaS environment, and most of them is sucked down into videos and in your factory, in your aircraft, whatever it is, right? And the economic question around, now how do I send that to a cloud? Or even if I send it to the cloud and then I want to decide a few weeks later I'd like to reanalyze that again, I have to pay to access all of that data again. So I think there's an economic model that also says filter story, I don't pay as much on networking, I think is a pretty important factor too. I think the one thing, if you really look out there in some of the future, there's new applications. You can't wait for a couple of milliseconds for a cloud to render an image on a physical thing that you're seeing or in response. Unique for the edge, starting to occur as well.
I think Sastry sorry, go ahead, Jim.
Yeah, I just thought of something to make the point. Now, we manage connectivity management currently for about 60 million things. We're just getting started. The general estimate, the best estimate we can come up with is things that could be called IoT devices. There's maybe one of those for every 6 people. Over the next 3 to 4 years, there will be 6 of those for every 1 person. If you take that unbelievable multiplication and multiply it times the amount of data that it's generating, there's no possibility.
An application with a budget, and I think you have some experience with video also.
Right. What I'd say 30 seconds about use cases, and I'll answer your question about the video. The use cases typically depends on the type of vertical that you're in, right? So if you're in a manufacturing, whether in a transportation, oil and gas. You need to talk to them about why would they pay for it. You walk into them, you provide a solution, why would they pay for it? So what exactly are you solving for them? Whether it's yield improvement in the case of manufacturing, or condition monitoring, predictive maintenance, proactively predicting failure conditions for them and things like that. Same thing when it comes to transportation. About was in a video use cases where traditionally, if you look at industrial guys, they've always been equipped with either some analog, more recently digital sensors. But in the past few years, some of the modern sensors like vibration, acoustic, audio sensors, as well as video cameras. So for example, if you have a corrosion in a pipeline, take that video and be able to detect and parse that. And you can't, but you have to do that in live in real time. You can't really send that all of that video data to the cloud. How do you do that at the edge? So that's one thing. The second thing is sometimes that video by itself, that data is not enough. How do you then combine that video and audio and existing digital sensor data and combine what we've been calling sensor fusion, meaning that at the same time, I look at the video, see that there is a problem, and then try to correlate how that problem is caused by, whether or not it's caused by looking at the audio sound of the corresponding machine, whether it's a compressor or pump or whatnot, and then further analyze to say, now that I've identified that there is a problem, what sensors are indicating me that is going to cause to that, lead to that problem. This is not an easy thing to do, particularly in a constrained edge environment. And those are some of the use cases where if you actually prove to the customer, you can do that in real time, proactively predict the failure conditions, save them a whole bunch of money, they're willing to pay what you ask for.
I want to tell you a big story. I'm a little worried that Ray is here because he could be the giant. But anyway, the story is the following. There's a huge number of use cases responding to deep pain points in the operational side of business. Particular, let's imagine a factory or a car making factory with robots, quality control, PLCs, and so on. When you get in there, you realize Daimler asked me, you know how many computers it takes to build a C-class car? 100,000. These computers are isolated machines. They are poorly networked, data is poorly extracted, networking is manually configured. It's a old infrastructure, 1980s. Windows 3.1, Windows XP exists. The infrastructure needs a new architecture. There are most of the use cases you can find. Virtualization is a big play that has in a small way is to bring some of these technologies to lift those applications without changing them over a much more modern infrastructure, redundant. All the use cases. And they are, obviously, when we go there, everybody likes it, but they say, these 25 people, I cannot give you the job. I cannot give you the job because I have to put your machine all over the world in all my plants, come back with a big guy behind, come back with Intel, come back with others. So, but those, we'll see, are the enormous business cases and use cases in front of us.
Jim, any kind of segments of industrial, like you mentioned, I think, smart city, someone else mentioned oil and gas. Any particular subsegments you think will embrace edge computing earlier than others?
Let's talk about IoT in general. I want to echo what Flavio just said. The infrastructure in manufacturing is really quite ancient and overdue for overhaul. You know, we do quite a bit of work with oil and gas. It's fascinating, both upstream drilling as well as midstream refineries, but there's not that many oil companies. We're the leader in city infrastructure, but you know, it's spending public's money. They're very careful about that, and so the sales cycles are long. You know, and energy, it takes forever to close an energy deal because the utility companies are very
regulated.
Yeah. So you kind of walk through the different segments. Now you might we can draw a couple of distinctions here. There's consumer IoT, which is currently about twice as big as commercial and industrial. The crossover point will be around 2020, and after that, commercial industrial will eventually be twice as big as consumer. Consumer is Fitbits and Nest thermostats, etc. High volume, low price points, etc. And you also see some people making the distinction between massive IoT, which is massive devices, versus critical IoT, which might be autonomous driving and the need to do things in a sub-second response time in order to protect human safety. Frankly, to net it all out, it's not manufacturing because there's three segments: semiconductor, discrete, and continuous. It's discrete manufacturing. That's where the action's going to be over the long time. They've got the devices, they've got a strong economic benefit to improve the processes in the factories. Imagine that you could reduce the cycle times of your CNC machines. Imagine that you can improve the productivity of your factory by 3% without any capital equipment. That flows directly to the bottom line, changes profitability, changes the shareholder value. That's a strong business benefit, and that's why IoT is going to succeed.
Any segments that you know of that he didn't mention?
So the other one I would mention, we talked about manufacturing, we talked about oil and gas, we talked about
Smart
energy
cities.
as well as smart cities and smart buildings. The other one I would mention, particularly, someone referenced earlier about the parking lots, and even things like elevators, moving equipment within buildings. It's all about how do you reduce the maintenance costs, whether it's a building, whether it's city offices or energy consumption, all of that. So we're seeing tremendous number of use cases in that. In general, the top four verticals that we see a lot of use cases, our experience is manufacturing, oil and gas, transportation. We didn't talk about locomotives, jet engines, autonomous vehicles, trucks, fleet management, all of that, followed by smart cities and smart buildings.
So Flavio will switch gears, and so I heard you say that PLCs are ancient, and so PLCs did a good job, seem to have done a good job, and a number of the large industrial vendors have done a pretty good job using programmable kind of PLCs to control systems in a very kind of reliable, ruggedized way. Kind of what's wrong about them, and kind of if you can help us talk a little bit about you see a whole array of hardware out there replacing PLCs, from kind of an ARM BB, and HP announced literally a kind of a mini data center on a manufacturing floor. Can I help us kind of understand?
Yes, so right now what we see is in that side of the world, strong capabilities to compute there, because the form factor, the power, and so on, that is easy to kind of start bringing in. Then you come down is a variety of industrial pieces. There are those kind of things. Obviously the networking part, and then you go to some of the control and embedded controllers. PLCs have been very successful. Nothing wrong with those, but there's a number of limitations there. When you want to start enriching the control with sensor data, with streaming data, with video quality that affects the decisions, it becomes difficult. Also the programming languages are a little limiting. Good, but they help people in that world to do it. We already saw the direction, which is the virtualization of the PLC. Virtual PLCs running on Intel machines are known. Maybe they have not been very successful because they have not yet demonstrated the full power of this paradigm shift. So what will happen is embedded stuff will be there. ARM will be probably winning that game. So there will be intelligence going deep into the robot root. Then there will be a next level, which will be more the fog or edge aggregate controllers. which will host in the, and quality control functions as virtual applications.
And
there.
dominated by Intel?
And potentially dominated by Intel. And in fact, this is the game. We tell Intel, this is your game. You are all in there with your industrial PC. They have good computing, good support for virtualization, sufficient security, even improved as we saw recently. But that's the game of local and then on the other side. But the key thing is models of computing, languages, also environments right now is all mostly with. So they have to coexist, and you have to do it through this kind of new architecture. And then, and networking will be embedded and also still separate, and so there's a lot to talk about. But this is kind of a first pass.
Probably the largest manufacturer of PLCs in
there's nothing wrong with PLC. So if you look at the evolution of PLC, right, it kind of like focused on the segment. 99.99, it has to be 99.99 and add another 9 and let's try another 9 on the top, right? That level of reliability is what PLCs are meant for. But it brings another angle to it, they become expensive very quickly. They are looking for a non-standard infrastructure, if you may say from IT standpoint, right? You want a PLC chassis, you want a PLC rack, it has its own power supply, you have the whole ecosystem, right? And you kind of scale there. And very soon, if your use case is not really creating a lot of value for you, it probably can become a value proposition challenge for you, And that's where we believe Edge really complement our customers, where the use cases, when the level of determinism, control, quality, accuracy, speed, we are talking a couple of milliseconds, right? Going up to nanosecond if we talk about motion controllers and all, right? If you don't really get advantage at that levels, then just for a use case which probably is some optimization, some visibility, some data compression, PLC might be an overkill for you, and that's where Edge really fills the gap quite well, right? And that's where we kind of believe it complements quite well. So from our standpoint, we see it a lot. The customer, based on their own constraints, it can start at a different level and migrate to another level, right? So there's no digital way to say what. If you're looking for very high determinism in your process and you want very high accuracy, you have compliances as a need, right? You are working on pharmaceutical company, life sciences, healthcare. You really can't take risk on anything, Obviously Windows, Linux operating system all are very good, But how can you establish to a but it adds a burden on the top. So kind of like looking at the both spectrum.
I would disagree a little bit on that, partially from someone who used to program PLCs in an industrial environment and so on. The reason why I said is when we first started doing virtualization, there was a whole series of concerns about I'm running two applications on the same box, so it's no longer the same timing. What happens if one application screws up? Are these things completely separate from each other, right? And it took that you want to go there. I think the same is going to happen with some of these PLC type devices and these factories where it is going to move into a more, I could say, a ruggedized version of something that looks a bit more standard compute. And when it does that, then, the same kind of compliance needs will appear, but the same ones that already occur today somewhat in data centers and so on. I have not in the last year or so, for the first time when I go in and talk to an IT person, when an IT person comes in to talk to us, there's often an operations person with them. That never occurred before. They were on completely separate, different planets in those companies. And so I think there will be a convergence on that broad software storage.
Right, and I actually agree with you to a larger extent. You know, like if you look at the PLC landscape, right? The convergence is happening where the compute surfaces, which are more of a territory of, like, I would say, small entry-grade servers, are right available on the PLC chassis itself. You know, so if you're looking for writing some program on your language of preference, you know, you can have a Linux environment which fits right into the PLC complement with the pieces, right blending at that layer. You know, so kind of like it really converges, and compute surface and all those things are not really the decision maker. You know, like it's a combination of many things which really drive what makes best sense for a particular user. Kind of like it's a true convergence, you know, which is coming top down, bottom up. So you look at it as a PLC vendor. Bottom ups, right? You're looking from control to infrastructure, analytics right on the devices, machine learning right on the devices, you know, taking edge to a little bit closer to, I would say, capabilities which existed traditionally on cloud-like applications, right? And kind of like other way down as well.
I can just chime in on that. I think I agree with most of the viewpoints there. There's really nothing wrong with the PLC. They've always existed. They've always had, you know, simple rules engine, ladder logic. They've always programmed that. I think what we're really talking about when we talk about edge, it's not necessarily replacing or changing anything in the PLC. In some cases, as we all talked about for quite a while, adding an additional small computing device, a low compute device that can do additional, more complex data processing and all of that. But what the trend that we're also seeing is that the PLCs themselves are evolving. PLC chassis, you can have multiple module slots. You can actually insert an additional slot, leave the existing ladder logic, PLC control logic in the way it is right now. In the additional slot, you put this additional computing, low compute, and x86 or ARM, doesn't matter which way, depending on your choice, you can do that. We've been seeing that quite a bit in our customer scenarios.
Go ahead, Flavio.
There's a very interesting initiative that is called the Open Automation Initiative, driven by Exxon, Shell, and others, for the future of distributed control systems. And there you see there's some very big, beautiful architecture pictures that describe this evolution of control, where there's the distributed, embedded, low-level control that remains distributed, and then there's a deterministic bus and network in between, and then there's a real fog edge computing that is the aggregator, that is the point of richness of orchestrated control. That is the evolution of the architecture of the autonomous car. That's the evolution of the automation cell. And that is fundamental. And there will be, and this is the story of Cisco, the story of Rockwell, there is a desire not to remain prisoners of the big, powerful legacy companies. And in fact, the fact that the PLCs will try to evolve in this thing, to some of the customers, is worrisome. They say, we want the new stuff to come in before they catch up. You know that very well, you know. So there's an interesting race to open up, open automation, open source, off-the-shelf compute, and so on, brought in to break some of these powerful holds. And the guys that are in there, they will have to rush and respond. If they don't respond, there will be a lot to lose. If they respond with some of those openness and flexibility, that will be a good game. It's a big game for you guys. It's tough to be a startup, but it's tough to be a big company too these days.
But when we talk to our customers, they sometimes complain about YAFB, which translates to yet another F box. And they don't want another box because of exactly what you point out. It deteriorates the reliability. So we shouldn't focus on PLCs. We shouldn't focus on edge computers, etc. We have processors everywhere. You know, there is a company who has a processor they're putting in a washing machine, and they have zero contact with their customers. They sell to Sears. Sears sells to the old lady. The old lady starts to do the laundry. It doesn't work. She calls the support. So what do? They reach through the Wi-Fi into the home, talk to that processor, which is an edge compute model, and look at the washing machine, and then instructs the lady how to do it properly, avoiding a truck roll and saving the company millions of dollars a year. Your washing machine is an edge processor. Your refrigerator, and everything is going to be edge because microprocessors are everywhere.
Ray, just wearing your hardware Dell hat. I didn't hear GPUs being talked about, and NVIDIA, just out of CES, NVIDIA, had just a whole lot of buzz. Where do GPUs fit on the edge?
So a lot of our focus here has tended to be on industrial, and we do have a lot of deeply embedded processors or small processors down in the system, where from a power point of view and everything else, the GPU is not necessarily a great fit. What we're seeing right now is that as people try and bring intelligence to the edge, they might leverage cloud, a very rich GPU environment in cloud to do training and so on, but they'll have the actual instances of then how do they use that model, not necessarily using GPU at the edge itself. However, that being said, a lot of when you get into boxes that begin to look like mini data centers, or let's use the word micro data centers, hyper-converged infrastructure and so on, you can readily get GPUs in there today. And based on that, I suspect you are going to see algorithms being able to leverage those and to work the extra power based on the performance to get to be able to do that. Surveillance is one of the big ones that
with cameras.
With cameras. Where it's not just a matter of compression, but you're getting into object recognition and so on right down there at the edge, and they can leverage those. But a lot of the things we're talking about here are very power sensitive, and a GPU is not necessarily the lowest power device that you can put into beside a Raspberry Pi or something like that.
We'll talk more about winners and losers on gateways. Do you think the hardware guys, Dell, HP, are these the winners? Who are the winners in gateways?
Of course I'm going to say Dell is going to be the winner. Realistically, there's a huge array of gateway vendors out there, right? And some of them very unique to particular industries. What I see is when you get into IoT, you invariably are getting into a vertical discussion with an expert in that industry. So, I can move in there with a VMware hat and say, we know how to do, data processing or run virtual machines and so on. But I don't know the nuts and bolts of, an island gas oil rig or an oil rig or something like that. So invariably you're working with partners who are experts in those spaces. And it's not unusual for them to bring their own hardware story to that mix. Quite often, right at the sensor itself, where gateways and so on are in there. What I do think is going to happen is, I do think you are going to see a real emergence of what you call the aggregators, and some of those are, relatively rich gateways, because I think that will be part of the security story. I don't necessarily, I'm not able to run sophisticated security analytics in my PLC, but I am able to have an aggregator device, which is a gateway of some sort, be able to run AI and understand what's happening on there. And I think security is going to emerge, and an isolation component is going to be important for gateways. By the way, the problem of really answering the question is, one person's gateway is another person's micro data center, is another person's extreme edge device. And so it's even hard to use the words there. I think aggregator is a good kind of way of looking at it.
Got it. Maybe we'll... Yeah, please go ahead.
Two quick things here. First, there is a resistance to bring another app box in if it doesn't solve the current proliferation of boxes in there. So we have seen guys say, don't bring menu box, whether it's gateway or, unless it really has sizable impact in solving many pain problems. On the GPU though, there's two big areas. One is the quality control, where video analytics detects defects and so on, helping the expert. Right now the expert is looking, and it can be complemented by a GPU through learning and so on. The other one is with robots. The robotic cells need to work now with humans, and you need to detect where the human is. Is it coming close to you? So again, the GPU can be a place for local detection and enrichment of analysis, video-based. That's one important application we see.
Great. We're going to mix it up with a few questions, and then we'll come back. Go ahead. Okay. Oh no, that's the
camera.
That's not the. Let me just go ahead. You're speaking into our camera.
No, to flip it on?
No, it's on.
All right. Can you hear me?
Maybe it's off.
Okay. Can you hear me?
Yes, we can.
Yeah, so coming back to constraints, what you described was kind of a rich implementation. And maybe some use cases need that rich implementation where some of the compute is on the edge, some it is on the fog, and some is on the cloud. But it also makes the whole implementation extremely complicated. And in a way, one could accuse you of taking us back into the client-server world of yesteryear, where now I have millions of devices, and if I want to update a model, I have to push my model down to millions of devices, and if 10 devices are off, they don't get the updated model, and then the data is corrupt, and so on and so forth. So it seems that in certain use cases, one may be better off saying, I don't want this complexity in terms of implementation. Just send all the data to the cloud, and then I'll do whatever I need to do over there, right? So maybe Cisco is better off making sure that we're never in this hostile network situation where every corner of the earth is connected to the network and has fast, reliable communication, and then 10 years later, we won't have to worry about this.
Yeah.
So that was one question. And then
One question at a time.
No,
So there were a bunch of interesting questions right there, by the way. One is about manageability. Cloud is clearly kind of, everything is centralized, easy to manage. In the scenario he painted, because the edge really has increased the manageability. Second is we're not that great in writing, secure, high quality software. And when you start spreading software all over, doesn't that lead to a whole problem right there?
Right, so you described my daily problem. So first off, there is a trade-off between simplicity, moving all the data to a central place, versus power by getting the leverage in all of the edge devices. And so there is a kind of a methodology to how you make those decisions. Secondly, there's very clearly different models. We refer to them as 2-tier, 3-tier, 4-tier. For example, you take a commercial product like the Nest thermostat, there's lots of them, but they all generate one type of data, one form of telemetry, and the guy who's writing the software in the cloud sits next to the guy who designed the thermostat. It's very simple. Compare that to a factory where you have 100 vendors who never talk to each other and they've got tons of different stuff. So we're going to do a lot more edge and fog at the factory in order to normalize that data, build the canonicals, than we would in a simpler model. And we will make it as simple as we can. Keep in mind, OT does not have developer shops. So, no, we're not asking people to write code at the edge in the fog. We're providing tools that generate the code for them. Very much point and click type of mechanism. We're providing a system where we can push things down and then monitor the system from a single place, all of which is required because of the highly distributed nature of it and the issues that you talk about. And when we push the stuff to the edge, which of the Flavio boxes are we pushing it to? Well, we have all kinds of different environments. Building, then pushing it to third-party boxes, like Dell, for example, what might build.
So Ray, doesn't sort of the having the edge now kind of open up the attack surface? What about the security part, cloud versus kind of?
Maybe just one comment to the question you asked. I think it's exactly what you say. You've got to look at this based on the application, what you're trying to do. And it is perfectly balanced. There's a great IoT situation which says, I've got a device which talks directly to the cloud and skips all of the stuff we were talking about here today to a large degree, right? It's just not going to be everything. You've got some very, very real-world constraints that you've got to deal with, particularly something like manufacturing or automotive and so on. The shop model simply does not work. But you're going to have others where it's perfect, and the next one I think is that perfect example of what's working. To the security side, I think the key issue, or one of the key issues when it comes to thinking through security in the IoT space is, in the past we've spent a whole deal of effort around protecting data, protecting identity, protecting information. So, and all of our security is geared towards that in many, many ways. Look look at Europe as it puts in new laws around data integrity and so on, it's all about protecting personal identifiable information. The problem is when you get into IoT, security is not around protecting information, it is around protecting an action. Or, you know, when you slam the brake on your car, the car better stop. And if that has been compromised in some way, it's much more serious than you know, losing access to your bank account for a few hours, right? So the impact, how you deal with things like insurance, how you deal with you know, responsibility and so on is fundamentally different when it comes to security in this space. And you know, our view of it is that you have to act in a world where you assume that the IoT devices actually are easily compromised, because you know, it's living at the top of a building. Somebody can physically access it. You know, most of the stuff in your data center, at least somebody cannot physically access it, at least not readily. Here, somebody can physically access it, they can replace it, and so on. And that requires a new type of security built into the infrastructure itself, which is constantly monitoring, trying to understand behaviors, identity, of what's happening, because there's vast quantities of information feeding into that network, and be able to make decisions based on that. And I don't quite think we've actually delivered those type of products yet. It's just emerging, and we're beginning to have to face that. But an old world of saying, you know, I build a bunch of firewall rules and I know what's happening based on that, I don't think it's going to work. It's too dynamic. There's too many devices appearing and disappearing all the time, and it's just fundamentally the impact of that security hole is just way more serious than the loss of personal identifiable information.
Let me add on to just a comment. A lot of the security today is to protect the system from unauthorized access from unknown people. And so we all know usernames and passwords. None of the devices that we talked about tonight know how to type in a username and password. And so how do we protect against an authorized device? So IoT does open up new attack vectors, and it does require a new security system. We are aware of this. There are a number of companies working together, much of the leaders, to create a model for IoT-ready devices. It will be in the chip in the device. There will be a configuration file in the device. The provisioning and connectivity would be automatic, because we can't live in a world of billions of devices that require somebody to authorize them. We're working on it. We're several years away from actually solving the problem.
It's a hard problem, because a device, you know, it's probably made in some other country like China, someplace. It changes 5 hands before it's actually put into production, and there's a high chance it'll be compromised. Let's take one more question.
Hello. Fantastic talk, by the way, guys. It was really great. I've heard a lot about today and how today works, but I came here because of the title, and I really kind of believe that we haven't talked about a few things like blockchain and like platooning of edge devices, and really understanding that maybe the cloud won't exist in a few years. I'd love to have your opinion on in the form of worms and viruses that we've kind of faced with compute power, how it can really get rid of the fog and the cloud at the same time. I'd love to know what you think the future is, if you could spend a couple of words to kind of...
Excellent question. Sastry, go for it.
Sure, let me chime in on that. You know, first of all, you know, I don't think that cloud is going to go away anytime soon. It might change forms, it might exist in different forms. Then that's a local data center, right? Cloud is more a hosted central data center location for many, many different customers and services out there. It will change its form. It will change its form. I think there is a little bit of a confusion, and not everyone in this room probably would agree with that view, that people have been thinking that there are 3 different layers. That unnecessarily complicates things, in my opinion, where you have a central out there. Technologies like blockchain and but the fact that you have edge nodes of the network, or Sun Microsystems used to call several decades ago, this network is the computer. That's how the Scott McNeely used to call it at that time, right? So we're still back to the same thing. Edges are those nodes. They will not go away. Now, which is why we're actually distinguishing between edges in an industrial context versus edges in a consumer context. The consumer context will get more and more complex. All of our cell phones, the devices at home are more powerful over time, will become more powerful over time than a typical computer that you see in a cloud data center. So again, my hypothesis is that yes, it will change forms. The cloud computing itself will not go away, and it might change names, it might change locations, but they will be compute at the edge and compute in a central location.
Yeah. I would like to see your question in terms of the new things that will be needed and will happen. Some of them in security, some of them in the way one model that could be helped to distribute security, decentralize and distribute security. Right now, we tend to need to go to the cloud, to the point of trust. The story of the guy that went without keys with his Tesla in the middle of the desert. The door of his car and had to have his brother drive 500 miles with a key. Shows you that you have to have a peer-to-peer distributed or decentralized model of security, and blockchain lends itself to that. The other one is the platooning. We call it federation. You cannot expect to have all the right amount of resources in every place, but you might have a sprinkling of those resources on an industrial floor, along the roadside, and so on. You have to be able to gang them together to do specific you help each other to compute. That's your platooning, and that is a very important area of innovation.
But is it fundamentally different from edge computing? We heard like cloud, edge is different from cloud. You have 10 drones on top of Afghanistan, no connectivity to cloud. They're communicating with each other. Is that fundamentally different?
No, but the problem is this: these technology advances are needed there because of all the constraints that we have and the need of not being connected. I don't think that we are going to create something totally new, but we are starting to insert new degrees of freedom, new models of distribution, new models of management, and so on, new models of security that respond to the new requirements. So that is the evolution of technology.
Any other thoughts on?
I'd love to get gems, if we could get gems too. I'd love
Yeah.
Sorry.
Yes, favorites.
What
Nothing.
abounded when the power of computing continues to explode at the rate of Moore's law? And what does it look like when, surprisingly, very few people realize this, the power of networking and the amount of communications provided by networks has expanded faster than Moore's law. So now the network is not the bottleneck, the network is everywhere. And what happens when we can talk about things as a service, whether it's an application or platform, which don't require cloud, because you've got networks and computing everywhere? And the answer is, beats the hell out of me. But it's the fun part of working in Silicon Valley. I mean, we see the problems today, we are consumed by the problems today. I guarantee before we fix today's problems, for coming tonight.
Are you closing?
That's the only thing I have to say.
Thank you.
Thank you, great panel. Bert Bonk with InfiniRel, stands for Infinite Reliability. You touched on time, control, and latency. If those things touch $1 million of revenue, how specifically start up with innovative, great products? How do you get your customer to adopt those products? What's the hurdle you have to jump through?
So I think we start with the startup.
Obviously, pioneering like this, and then they have to start deciding if they want to commit to a startup that may not be there 2 years later. So that's the delicate time. But this is the time when a coordination, collaboration between large companies that are becoming slower, much slower in system and a collaboration and a support can be unbelievably important. And so we believe that there will be, first of all, an ecosystem of companies, of small companies. Now, it's not one company that has it all. And there's an ecosystem including the large companies and the small companies where you can guarantee the life of this startup. You can protect it, you can push it, you can absorb it, acquire it. That is the game. Because in fact, before they deploy worldwide, they'll go to some big guy and say, can you please buy this guy, this company? It has happened to Cisco all the time. You know, you said, I like this thing, but you bring it in yourself. And so there will be mergers and acquisitions, hopefully successful for many of us, hopefully. And then we'll become part of a bigger effort. And the other one is the silicon companies, you know, the Intels and the Qualcomms and so on, they can also be behind the innovation. But it has to be a positive ecosystem play. This is too big.
So I will, the short answer, it is difficult. Of course, it's not easy. That's why we exist. That's why startups exist, right? There are two things that are really different about this. One, general typical startup problems. Two, what's actually different about edge computing and IoT in general. In a typical IT project, you actually go into a CIO whether it works or not. In an IT, OT environment where you walk into a factory, you walk into the turbine, right? It doesn't quite work like that. The operations guy who is actually operating the machine needs to feel like he actually is going to get benefit from it. He is actually, in fact, going to improve the operations of the machine the way he thinks that it is going to help. So the first order of business is to really understand how is the software, how is the product that you're going to sell to this guy. The second part of it is, there is of course the startup problem. When you're a small company walking into the big guys and say, well, I've got an innovative product, who will listen to you first, right? So it's always a challenge problem. This is where, of course, every company has a different strategy. For example, we followed the strategy where we have been backed by one of the most big industrials out there on the globe. The GEs and the Honeywell, Yokogawa's, Bosch, and technology partners like Dell and Intel, they're all backing us up. And who best can explain, for example, how a jet engine works or how a locomotive works than GE can, for example. When GE walks with you into the customer, they say, look, this solution actually works, and by the way, it's actually part of larger Predict solution as well. That gives us a little bit of a boost there too. There are a number of different strategies that we can follow, but it's not easy. Obviously, if it's easy, everybody would be a startup. Every company, every person in this room would start a startup, right?
Let's switch gears. Ray, 5G, what does it do? Because you know a lot of the edge and cloud issues have network kind of origins. What does 5G do to this whole equation?
So I think it's not just 5G, but it's virtualization and NFV. The combination of all of these things, I think, is where you're going to see some of the differences. Actually, somebody was mentioning the platooning, right? And I think when you look at the big picture, what I think is going to happen is a lot of the things that you think of the cloud are going to just become somewhat distributed across today what we might call the edge or the private data centers. I think a lot of that is also going to move out into the telco infrastructure. That's easy to say in some ways, right? And you know, when you asked about the future, I don't think it's suddenly going to happen next year by where, you know, somebody builds applications and the applications dynamically move across a telco infrastructure or across a cloud and off-prem based on the dynamic needs of those applications. Conceptually, of course, it's possible, but at some macro level, I don't see that happening really quickly. But I do think that will happen. I think it will happen because today when people use cloud, you know, I used to get asked questions about how fast is that processor, or what's the ability for that piece of software to be able to process something in a certain timeline, or is that backup, how is that redundancy? Is there redundant power supplies in that box or something? I don't get asked that anymore. They say, I'm buying a service from you that says you're supposed to run my application. And they don't even begin to necessarily ask questions about where it runs. I think the same will begin to occur in the future. And I think it will begin to move out to some of the telco infrastructure as the needs are there for real-time behavior and so on at the edge. And I think 5G is just the beginning of that, where you're beginning to get the connectivity and the applications that are beginning to play in that.
So today, telcos who were trying to play in IoT kind of struggle to define their existence. Does that bring them back into the game?
I'm not sure you would necessarily, and you know, a telco might have a very different answer to this. I'm not sure they actually even necessarily look at it as IoT. I think it is more about the ability to take applications and push them out into this edge type of infrastructure. Now, those applications may be doing things like, you know, looking at the IDs of people, as opposed to looking at something, you know, very IoT-like. So even in the absence of an IoT story, I think that's likely to occur.
Jim, what's your view on IoT and 5G?
I think 5G is just the beginning. You know, there's a richer array of protocol work that's underway that most of the people in the room don't even know about. There's even a standard called IoT-DM, which is specifically designed for IoT. How are we going to do smart grids when the substations are these things that look like gigantic capacitors with fences around them that you see as you drive down the highway? There's no buildings, there's no networking. We're going to do it with metropolitan area networks. And so connectivity becomes more and more ubiquitous. The bandwidth continues to explode at rates. I'm totally on board with what Ray said. The hard lines that we draw now about the cloud will get soft. There will be cloud functions and places that we don't consider the cloud today. It's just going to be completely distributed, and it will evolve over time in ways that none of us can really predict.
Let's take 2 more questions from the audience. We'll first give someone else a chance. Any other questions?
Oh, that's good.
Can
you hear me?
Yeah.
Good. In 2009, I was with a startup, and we did a durable medical equipment, and our edge was a Samsung S1. The difficulty we had was that and one of you guys referred to this, non-unification of interaction between the devices. They have their own wiggly commands, completely different, they're extremely secretive. How are we going to unify those before we even get to the edge? I mean, capturing all those bits and bytes is, with all due respect, how are we going to address that? And I've been involved with this thing for several years now.
So if I understand the question correctly, you're talking about how do you make sense of the data? Data collection itself is easy. That's what you need to come up with some domain knowledge, domain-specific modeling of what each of these different sensor data streams actually mean to you, what does failure condition look to you? Before you start even saying, well, I can just make something out of this data and solve your problem, you need to understand what are the problems for and express that, whether in terms of, in our case, we have an analytics engine where you express how does the customer express what it is that they're looking for. In other cases, they may not be able to express that. This is where technologies like machine learning and AI come into picture. How do you do some deep learning on that?
A bit of a clarification. IP for medical device equipment send bits up. They are unified in their feature set. They monitor your heart. We send monitor, we receive monitor, we send control. They are completely different. When I send it to the edge, I have 4 different interfaces to them. It is not like a unified edge interaction to 4.
That is correct. Obviously, we're talking about specifically how each product is solving all of that. The way we did is that right. So the way we did is we have a common uniform interface for what we call, a message data interface. Regardless of what protocol, what elements are coming in, they all get normalized into a common interface, and that is the starting point where the data gets analyzed. It's obviously every product looks at it differently, but that's how we address that problem.
But is your question related to the fact that there's a secrecy associated with that? So it's not normalization. It's each of these devices, these companies are not being open or something like that. Yeah.
But this is the whole effort where the IT world coming in, Industry 4.0, all these digital areas that were created for many, many reasons and protected for many reasons. So in the industrial, for example, the field bus is evolving towards what is called TSN, time-sensitive networking, which is Ethernet, IEEE standardized. The middleware a lot of the middleware from the IT world. So the effort is there. We realize that if they don't talk to each other, we don't gain much. And so the impact of the IT world with its model of standardization, interoperability, web interfaces, APIs, and so on is coming in to help, but it's a long journey.
Yeah.
So all these questions are related. How do startups survive? Startups get there before the big companies, and they provide and they take the risk to do that. Why will devices move to a common interface, an open interface? Because their customers will demand it. And we're seeing that today in utility companies, where the private interfaces are breaking down. And all of our companies, we have OLTP databases that the data is populated by common transactional applications. We want to do reporting, so we have to pull all of that data together into a warehouse. How do we get data from 4 IoT devices into a canonical model? It's kind of very similar to ETL, that it's on a real-time basis. How do we solve the problem that all the databases are different and all the data warehouses are different? You don't build a common mapping, you build a powerful easy-to-use tools, point-and-click capability to mine the data from the devices, whether it's OPC or whether it's MT Connect or whether it's CIP, and then transform that data and then putting it in a system where we can do it on the fly, one piece of telemetry at a time. It will require work, but it's the same work that IT groups have been doing for years.
Really applies to all use cases. When you talk about any manufacturing plant, all the legacy equipment would attribute these behaviors, right? And they would show it in and manifest in different ways, kind of that, right? It's really a challenge. There are different ways we are kind of looking at it at this point of time. There's no perfect solution, but there are different approaches, right? One of them, obviously, for companies like ours, right? prefer our edge component, edge platforms, right? We have better understanding of devices which actually came from us, like maybe today or maybe came like a couple of decades before as well, right? So that kind of one area where it simplifies in certain ways. But in addition to that, unsupervised learning is also offering us advantage where the ambiguity of this is where there could be multiple parameters which are coming from the process, which process parameter influence my area of interest the most, right? To the conclusion, and the conclusion can change, right? How some form of unsupervised learning can get me closer to where I want to be and put my engineering effort that might not work. These are kind of different ways which doesn't eliminate the problem, but make the path to solution shorter than what it was probably a couple of years back, right? Kind of.
Question? Gentleman with the glasses? This gentleman.
We have
Is there another one? Go for it.
The glasses.
He's got glasses too.
Up to date on fog computing. One of the things I've just been thinking about, and we have a lot of luminaries from networking companies here, a lot of changes in SDN, software-defined networking. What do you see happening with SDN which can help not change so much of the hardware out there, or the edge hardware and the IoT devices, and minimize, trying to upgrade all the stuff out there? Any update?
That's a
for us?
Cisco question.
That's probably where I might disagree with you.
So, my first reaction is that SDN is centered around a control plane. How do you go to a single place and configure devices, even if the devices are multiple vendors? But IoT is a data management problem, not a control plane problem. So we're focused on the data management issue. When the surveys are given about what's the most important issues with IoT, it's not analytics, it's not applications, it's data management, but it's real-time data management. I do believe we need better tools for managing networks. I do believe it needs to be centralized. I do believe that we need to open multiple vendors, but I think IoT is a different problem.
Oh, I think when you look at the new, and Ray probably, a new fabric in there with distributed computing, there has to be networked, there has to be virtualized, there has to be managed in a modern way. This is all SDN. In fact, software defined is playing in the network, is playing in the control, is playing, is fundamental. And it, for example, there's a company called Veracity that is when they see anomalies, they cut off certain machines in one shot. That is a very nice application to security of software-defined networking in the
I think that we probably have slightly different views of software-defined networks. From VMware's point of view, like our whole bias is make it software. No matter what it is, make it software, and then you're going to be able to figure out how to manage it in new and different ways. But in the context specifically of IoT, and maybe broadly more in the is it's inherently dynamic. Everything you've got here are things that are changing all of the time. So you want to change your security stats, you want to change your networking configurations, you want to bring a whole new swath of servers or IoT devices or data centers into the mix. With a software-defined network, all of that becomes essentially a network connectivity, and I can do it very dynamically. And you can stretch that all the way out even into, some of the discussions around NFV and what will be happening with the telcos and so in the future. So I do think SDN is a key component in this mix, and I
So the thing I would tend to share that same viewpoint, SDN in general, while it's not specific to edge computing or anything, it does help with management of distributed nodes in a software-defined way, right? It just so happens if you have a multitude of edge nodes connected to SDN, it will make it easier for you to detect whether it's security problems or routing.
Could we take one question, please? And then we're going to wrap up after that.
Thanks. Again, excellent talk. So one question I had, which has been alluded to, is this impedance mismatch between and then we also talked about attack vectors, but it seems that some of those attack vectors can become really large in scope. Like, for example, we're talking about a nuclear reactor or a hospital or the energy grid, in which case it becomes more like a national security issue. So do you guys see kind of law and policy keeping up in terms of, hey, what can you do with IoT, or is it just like the Wild West where you just go talk to a company and you decide to do it and that's it?
Well, if I can chime in first, I think that is the fundamental reason why a lot of these sensitive as well as expensive, confidential, however you want to put that, those machines are typically not going to be and never going to be connected to the cloud or the internet or to a public network. And this is all the more the reason. In fact, your point is the one that's supporting the need for edge computing, where the processing, local data processing, whatever things are happening next to the machine, local to the machine, data never ever gets shipped to a central environment, potentially subjecting it to cyber attacks, cyber security attacks. That's in fact a supporting point.
I think we'll just do a kind of wrap-up question. So we all sort of violently agree about edge and so forth. So let me do a contrarian play as in conclusion. So if kind of the TechCrunch story 5 years from now is that edge never took off, all the startups collapsed, Cisco is doing something else now, what is the reason going to be? What are some of the reasons why edge won't happen? So I'll give you my personal. We tried to bring Eric Balderschweier, the founder of Hortonworks, to be a founder at FogHorn. He said, "Are you crazy? You're Luddite. You're moving backwards." So, what are your thoughts on why edge would not happen? What are some of the reasons?
So I think it's kind of unlikely, but if it do happen, there probably could be reason about the positioning of what we're defining it as an edge, because it really has overlap in so many different things if you start looking from those different angles, right? So edge as such, as stuff, right, would exist, but it just won't be called in that way, you might call it virtualization. I'm just throwing some names, right? You might call it control system, you might call it reliable control system, But in true sense, edge existed like decades before. It's going to exist for the next couple of decades. It's never going to go away in the real substance, but the way we approach might change.
I think my answer is that the progress in processors, the processing, networking is inevitable. It's enabling. People will find
I think I'd basically say the same thing. There will be something out there which, if not called edge, is a close relationship between what's happening. Whether it's your connected car, whatever it is, I think that's definitely going to happen. I think the challenge is, though, if you want to say where I think edge in some areas, such as industrial, sharing data and so on, and I look at networking, the huge growth in networking over the years, would that have occurred if networking had not settled on some, really powerful standards? So I think there are barriers there, but one way or the other, it will happen. It just might be more difficult than we'd like it.
Thank you.
Yep. I think we seem to be all violently agreeing on this particular viewpoint. The edge as we know today may or may not exist 5 years from now. It might be called something else in a different form. But one thing is certain, distributed, localized processing of localized computing is given. It's going to happen. We have seen that over and over and again. It might change its name, it might change its form, but it's given, it's going to happen. It might be called something else.
But there's already, as and so it's there. The question is how quickly it will impact in operational industries and how quickly startups will be able in acceptance, in commitment, but it's inevitable. It's going to be there. No way back. Of the automobile, a fog node on wheels, or 4 wheels. There's a fog node on 4 wheels. And now, if you look into the website of BMW and Toyota, you see the architecture where there's a centralized, maybe redundant fog node or edge node, centralized, and then sensors. This is the architecture of the future of the car. We don't go back. That's fog computing, edge computing.
Thank you, gentlemen. Pradeep, Jim, Ray, Sastry, Flavio. Thank you.